In this lesson, we're going to write some unit tests for our DevHabit application. We'll create our first test project, and I'll demonstrate how to write your first test and what are the components inside your system that you should be testing when it comes to REST APIs. This is an important remark that I want to make right from the start. My focus in this chapter is testing our API surface and demonstrating what the different types of tests can and cannot test. So when it comes to unit testing, you will see that they are not particularly practical for testing our controllers. More on this in just a moment, but they can still be used for testing some of the behavior that we have inside of our system. So let's jump into the code and see how we're going to implement this. Before we introduce our test project, I recommend that you download the latest version of the source code that will be available from right under this video, as I've made a couple of improvements to the DevHabit application behind the scenes. Now let's see how we're going to introduce our first test project. I'll create a solution level folder and I will call it test, and this is where I'm going to define my test projects. Let's right click on this folder and add a new project, and I will be using XUnit as my test framework because it's the most versatile option. So let me introduce a new XUnit test project. I will place it in the root folder of my application where the API is also located, and let's call this DevHabit unit tests. Let me click next. I will use .NET 9 for my test project, and then let's scaffold the project. Out of the box, we're going to get a default test, which I'm going to remove, and then let's take a look at the project file. You'll see that this project isn't using central package management, and this is a problem because we won't be able to build it inside of the solution. So I'll have to take these NuGet package versions, move them into the directory packages props file. Let me, for example, add a remark that these are going to be my testing libraries, and I'm going to add them right at the bottom. Then I'm going to change package reference with package version, and with this in place, I can go back to my project file and omit the version references from the package reference definitions. Let's also omit the target framework, implicit usings, and nullable reference types, as all of this is also defined in our directory build props file. So this is all I want to have inside of my unit test project. Next, I'm going to add a reference to the DevHabit API project. You'll see a new element show up inside of my project file. You could also add the reference manually by right-clicking your project and saying add project reference. This is also going to achieve the same result. One more thing I want to do is go into my DevHabit API project and introduce another item group at the bottom of the project file, where I'm going to expose any internal types to my unit testing project. Now, we didn't use internal types too much while building our DevHabit application, but this is a common enough use case that I wanted to mention from the start. So with this setup, you'll be able to reference internal types from the DevHabit API project inside of our unit test project. So let's go ahead and close this down. I will also close down the directory packages props. However, I want to make sure that I'm running the latest version of my NuGet packages. So I'm going to say manage NuGet packages, then go into updates, and I'm going to select all of the testing packages that I just defined, and I will update them to the latest version. This is going to make the appropriate updates inside of the directory packages props, and now any future testing project that I define can just use the latest versions. So this is an awesome thing that's enabled by using central package management. So now I can also close this down, and we're also done with the project file. And now let's consider what we can actually test using unit tests. These are simple tests that should test a small component in your system in isolation without any external dependencies. So let me take an example of a controller. Let's say I open up the entries controller. This is something that you could unit test by initializing a new entries controller instance, providing mocks for any dependencies like the database context, the link service, the user context. However, our solution isn't designed to be particularly unit testable, and I did this kind of on purpose. First of all, to limit the number of types that we're going to define inside of our codebase. It's not really necessary to have a class and an interface definition for every type in our codebase. This will make unit testing with mocks easier. However, it also complicates your code without adding too much value. But this is just surface level. There is a much bigger problem when it comes to unit testing controllers, and that is the fact that the controller type has a lot of internal components. For example, if I type out this and take a look at all of the properties that are available on this type, you can see we have a controller context, an HTTP context, the model binder factory, the model state dictionary. There's the URL helper that we could have used for implementing hypermedia. There's the claims principal representing the current user inside of your system. And if you reference these properties in any of your tests, then you're going to run into a problem if you didn't properly set them up in the arrange step of your controller. The second thing I want to consider is what are we going to unit test here? Let's go to some post endpoint for creating the entry, like this endpoint here. And this behavior here is something that could be unit testable. However, because it's inside of a controller, unit testing this is going to be very complicated and not really worth our time. So this isn't something I want to test using unit tests. Instead, I would rather use integration tests or functional tests to make sure that this functions as intended. Now, if this code representing our business logic was properly isolated inside of some use case or even a service class, then we could consider unit testing that because we don't have the internal dependencies of a controller. This is just a trade-off that I made for this application, and I did it on purpose, but I feel that it's important to highlight when it comes to unit testing. So if I won't be unit testing my controllers because it's not a good use of our time, what are we going to unit test? Well, let me give you a couple of examples. In the services folder, we have, let's say, the encryption service, which doesn't have any external dependencies. So I can just create an encryption service instance, provide the encryption options, which contains my master key, and I can go ahead and test the encrypt and decrypt method and make sure they function as intended. Another thing I could test is the data shaping service. I could use an existing DTO that we have here, or I can create a custom one that I will only use for my tests. The GitHub Access Token service is something that we could unit test, for example, with an in-memory database context instance, although this isn't something I recommend too much, and we can create an encryption service instance and use those to test the behavior inside of the GitHub Access Token service. Here we could test the store async method, the get async method, as well as the revoke async method, and confirm that the behavior that we have defined here works as we would expect. Something that's a bit more complicated to test would be the link service, because it depends on the link generator and the HTTP context accessor. These are components that are heavily tied to the ASP.NET Core framework, and they only work inside of the context of an HTTP request. So unit testing something like this is very cumbersome to set up, and it's not really worth our time. We would be much better off if we were to test this using integration or functional tests, where we can send a request to our API, invoke the link service, and then confirm that we get back the correct result. Something else you could test is your mapping behavior. For example, all of the methods inside of our mappings classes are static and they are easily testable. We would just need to create a new entity instance or a new DTO instance and confirm that the mappings to and from these types work as intended. Another thing we could unit test is our validators. We can new up a validator instance, create a DTO object, pass it to the validator, and confirm that the validations work as intended. So I hope you're getting the idea of what I'm trying to illustrate with this. So let me close down all of these files. I will also drop down the DevHabit API project, and then let's actually write some unit tests. So let's say I create a new folder, and I will call it validators, and inside of it I'm going to define a new class. Let's call it the create entry DTO validator tests. Let me adjust this type. I'll make it public. We could also make it sealed, but this isn't particularly useful for unit tests. And then we want to define our system under test. And this is just going to be our validator. So let me create a new instance of the create entry DTO validator. And I can just new up an instance, and I can go ahead and write my first test. How you define a test with XUnit is using the fact attribute, and then you define your test method. So let me define a method, and inside of it I want to have the arrange, act, and assert steps, which are going to represent my test behavior. Now let's talk about test naming. The naming convention that I like to use is what I'm testing, in this case the validate or validate async method. Then I describe what should happen, let's say should succeed, and then I describe under which conditions I'm executing this test. So let's say validate should succeed when input DTO is valid. You can be as detailed as you want to be. Now let's see how we're going to define our test case. I'll define my DTO, which is a create entry DTO, and I need to set a couple of properties. So first there's the habit ID, and I'm going to use the habit entity to new up an ID instance. I encapsulated the logic for defining new IDs inside of my entities, and this is one of the improvements I mentioned at the start of the lesson. I'll set the value as 1, and for the date, I'll say date only from date time, and let's take the current time and see what's going to happen. Then I can say validator, and because I'm running an asynchronous method, I can call validate and pass in my DTO instance. This will return a validation result, and now I can write my assertion. So I want to say assert true validation result is valid, and I can also assert another thing. Let's say that my errors collection is empty, and I'll specify assert empty validation result errors. Now, if I wanted to test the asynchronous version, because this is what we are using inside of our code, I can switch this to be validate async and just await it. So we have our first unit test. Let's go ahead and execute it and see if it's going to succeed. And you can see that our first unit test is passing. So now I can go ahead and write the remaining test cases. For example, I'd want to check the failure conditions inside of my validator. Let's say when the habit ID is empty, when the value is less than 0. And let's quickly see what a test like that would look like. Let's say I specify string empty for the habit ID. I'm going to update the name of my test by saying validate should fail when habit ID is empty. Then I want to assert that is valid is false, that the validation result errors contain just a single value, and this also returns a validation failure if there is exactly one. And then I can say something like assert equal, specify the name of create entry DTO habit ID property, and I want to assert that the validation failure property name is equal to habit ID. So let's go ahead and run our second test case, and you will see that it's succeeding, and we are confirming that our validation rule that is checking that the habit ID is not empty is working as expected. So this can be a very practical and easy way to unit test the behavior of your validators. Now let me show you another example. I'll create a folder here that I will call services, and I'm going to add another class inside, which I will call the encryption service tests. Let me set up my test class. What I'm going to need is an encryption service instance. So let me import this type. I'll define it as encryption service, and then I need to create a constructor because instantiating an encryption service is a bit more complex. I need to provide an iOptions instance of the encryption options. And we have a couple of ways that we could approach this. For example, I could mock the iOptions instance and configure the mock to return a master key, or I can say options create, and this lets me create a new instance. And I will just need to pass in a new encryption options instance and specify the master key. Remember that we are using a base 64 encoded string. So I'm going to say convert to base 64 string, and I'll use the random number generator to generate a random 32-byte key. This will give me back my options instance that I can now pass in to the encryption service, and this should properly initialize it. So now I can go ahead and write my first test case. I'll write the most interesting option first. So I will say public void decrypt should return plain text when decrypting correct ciphertext. Let me define the arrange, act, and assert steps, and then let's see how we are going to write our test. I'll define a constant string value to represent my plain text, and let's say that this is some sensitive data. Then I'm going to define the ciphertext as encryption service, and I can call the encrypt method and pass in the plain text. Then we're going to get the decrypted ciphertext by saying encryption service decrypt. We can pass in the ciphertext variable that we have. And what I want to confirm here is that the value, which is our plain text, is the same value as the one that we get back from the decrypt method. So let's go ahead and run our test case and see if our encryption and decryption is working as expected. And you can see that our test is passing. So this is how I can unit test my encryption service. I can go ahead and proceed to do the same with all of the other validators and all of the other services that I have, but I think you understand my idea of what I'm trying to do when it comes to unit testing REST APIs. In this lesson, we tried to discuss unit testing REST APIs, but it ended up as me convincing you not to unit test your controllers, which I firmly stand by. It's not a good use of your time, and instead you should be unit testing your individual components, like your validators, your DTOs, your services that are unit testable, and this will be the best use of your time when it comes to unit testing. Now, I also don't want to leave you with just a few examples of unit tests, so in the next lesson, I'm going to write a more complete unit testing suite behind the scenes, and I'm going to walk you through the unit tests that I created. So the idea with the upcoming lesson is to give you a more complete picture when it comes to unit testing.